Okay, so in this video then, again, we're looking at friction, and we're going to use the idea of friction in addition to the rest of the information that we know to solve this problem. So we're looking again at that first block that was 10 kilograms and had a coefficient of friction, of kinetic friction of 0.3 that was told to us in the first part of the problem. And I believe that's it. So again, here's still our system. And now, instead of our force being applied horizontally, our force is applied at an angle of 35 degrees with the horizontal. Okay. Otherwise, everything else stays the same. So when we're drawing our free body diagram then, we need to first figure out, well, what are our agents? Well, we know that the Earth is still applying a force downward. So we have a weight force or a gravitational force. We know the floor is still pushing upwards with some normal force. We know that there's still a frictional force opposing motion, and we know now that we have this force F at an angle. And if we were to draw our coordinate axes here, vertically and horizontally, this angle would be 35 degrees. Okay, so then there's our setup. At this point then, we don't know much about our net force because we don't know if it's accelerating or not. So what we first need to do is we first need to figure out, okay, what are my forces in my x direction? What are my forces in my y direction? Well, this force at this angle is going to have both a vertical and a horizontal component to it. So we can't write our net force equations until we figure out what those vertical and horizontal components are. Remember, we don't want forces at angles. We want forces that lie along our x and y axes. So if I take my information here from the start of this and I say, well, here's my force, and I know that this breaks up into some force horizontally and some force vertically. Well, the force horizontally is going to be whatever the hypotenuse force is, or the force, times the cosine of my angle. And the force vertically is going to be the force times the sine of my angle, just using right triangle trigonometry there. So in this case then, my force horizontally is going to be, well, I know my pull force in this case is 50 newtons. So F is 50 newtons. So 50 newtons times the cosine of my angle, in which case my angle is 35 degrees. My vertical force then is again that force, or that 50 newtons, times the sine of my angle, or 35 degrees. And when I put these into a calculator and I solve for what this is, my horizontal force is 40.96 newtons, and my vertical force is 28.68 newtons. Okay, so again, this is the setup. If I wanted to draw a new, almost usable free body diagram for solving, I would say, okay, I have a gravitational force downward, I still have a normal force upward, I still have a frictional force leftward, but now instead of having this force at this angle, really what I have is I have some vertical force Fv and I have some horizontal force Fh. Okay, and this is mathematically equivalent to this. Alrighty, now what I want to do now is say, okay, what are my net forces? Well, I know my net force in the y direction is going to be the sum of my forces vertically. So I have an Fn up, I have an Fv up, and I have an Fg down. So there's how my vertical or my y coordinate forces align. Horizontally, or in the x direction, I have a Fh pulling in the positive direction, and I have an Ff pulling in the negative direction. Again, I've defined positive as this way and positive as this way. Okay. Now, I know this block from the scenario isn't accelerating vertically. Because of that then, I know that the sum of my forces in the y direction is 0. So then, Fn plus Fv minus Fg equals 0. Well, I already know what FV is, and I know what FG is simply from using my equation again. So 10 kilograms, 9.8 newtons per kilogram lets me know that Fg is 98 newtons. So I know FV, I know Fg. Well, if I want to calculate a normal force, in this case my normal force is Fg minus Fv. So my normal force is 98 newtons minus 28.68 newtons. So I get a normal force which is equal to 69.32 newtons. Okay, 69.32 newtons. Think about that now. That means that the floor is holding up the block with 69.32 newtons. That means that the floor is not holding all of the weight of the block, which makes sense because we're pulling upwards on this block a little bit, so this upwards pull is also holding the weight of the block a little bit. So we would expect that normal force to be less, in which case it is. Great. Okay, now using that normal force, we can solve for other parts of this scenario. So, for example, if we want to calculate a frictional force, well then remember a frictional force is simply a normal force times a coefficient of friction. And in this case, we have both. We know our coefficient of friction is 0.3. We know our normal force is 69.32 newtons. So our force of friction then is just those two values multiplied by one another, or gives us 20.8 newtons as our frictional force. Then again, if we wish to calculate an acceleration, we would take a net force divided by a mass. We're only accelerating in the x direction, so a net force in the x direction divided by the mass. So my acceleration then is my net force in the x direction, which is Fh minus Ff divided by a mass. I have all of these values. My force horizontally is 40.96 newtons. My frictional force is 20.80 newtons. And my mass is 10 kilograms. So then I get an acceleration rate of 2.02 meters per second squared. Again, given my system, identify the forces that are acting on my system. If I have forces at an angle, they need to be broken up into horizontal and vertical components. Then, using a new mathematical free body diagram, which isn't an actual situation free body diagram, but helps us solve easier, determine a net force, figure out how my net forces apply to things like a normal force, or a frictional force sometimes, and then using that information I can solve for an acceleration again by using a net force equation. So, net force then, remember, is simply the sum of the forces either in the horizontal direction or in the vertical direction. An acceleration can be determined using Newton's second law of motion. Then this acceleration can be used for a whole wide world of kinematics equations. Okay? Keep using this information as you practice.